Where do we do agitations? We normally do them in agitation tanks. What do we need? Well, of course the vessel and the impeller, which is here. If you have the impeller, well, you're not going to move any fluid. Also, you need a motor which is rotating and a shaft that gets the motor in contact with these impellers or propellers. Baffles are many times added to improve mixing, even though it's not necessarily. You could actually go down to your kitchen and check out the blending machine. It has this stuff right here, which makes or promotes more random movement or agitation. The circular tip, well, where is it? Here. And normally you will also include the level indicator, which will be like this. Because actually you don't know, because this is a steel vessel, you won't see inside, so you don't know if the propeller is moving or if it's static or the fluid is agitated or not, so you need to have a level indicator. You will have definitely an inlet pipe which will show the feed, shower the feed, and the outlet pipe which might be the same as the feed pipe, or probably you're going to have it right here, goes the product out. Common equipment needed: you need an impeller, which is a set of either propellers, paddles, or turbines, more commonly propellers. The baffles I told you about, and the tank or container or vessel. So what's an impeller? Well, the impeller type are propeller, paddle, and turbines, the most common ones. And these are the impellers, just blades, random blades that move the liquid. So you may have many different styles. Common styles are 3-bladed or even 6-bladed, or this is actually a paddle. And this impeller, turbines, maybe this one I don't see that much. But essentially you have these are paddles. This is very curious one. This is almost like a mill. It takes water and so on. Anyways, we're going to study axial flow and radial flow. Why do we want axial? Because maybe parallel direction is what we need. Radial, you need tangential. So we're going to see that later. Impeller type, the propeller, I think this is the most common one. Cheapest one, easy to model. You have the shaft right here and starts moving, and of course it's like a fan. It moves and moves fluid. Here you have the shaft, the vessel, the out or the valve that closes and opens, and here's the outlet, and the impeller, which here is a propeller, and actually you have two. One, maybe this is 5 meters. Oh, here we have a baffle, and here's the other impeller. Sorry, the other propeller. So we have 1, 2 here in order to improve the mixing. So what or how does it move? Well, it starts moving here, rotates, and what you're going to generate is this type of flow. Another example of the impeller or the propeller. All propellers are impellers, not all impellers are propellers. So propeller, as the name implies, propels the fluid. Now, impeller type turbines, well, as you can see, it's very similar to those turbines you've been studying in thermodynamics and even in pumps. And you don't need to be a genius to know that if it moves, this is going to move the fluid. Some example of how can you build one: you have the upper disc and the lower disc. Another type of turbine. Look how this is going to move the fluid. As this moves or rotates, you can even model it. SolidWorks probably. And then I will say this is the most antique way to move fluids is the impeller or the paddle. Paddle is the type. So it's very used in mills. So for example, you will have a mill that moves with water. Water will go here, move it, and make the mill move. Very basic, very useful, even though industrially is not that specific, but it's pretty, let's say, pretty basic. The turbine is not that, also it's kind of fancy, The most common one I will tell you, it's, or at least that I've seen in the industry, is the propeller one. So this is, I was telling you, you move these paddles, and the paddles literally move water away. But you know, for any force, you need a counter force acting against it. So you're going to move the water right here, but you're also going to move the ship. More on the paddle, you have here, here, here. Paddles, well, easy to. Hopefully, it's easy to for you guys to show. These are the paddles, and you can have, of course, different designs. And these ones are a little bit more fancy, guys. You're going to have a double helix, which is for high viscosity. Why high viscosity? Because if they start sticking in the vessel, you need to move them, and they move, and they move, and they move, and once they are down here, then they start going up and up and up, and then they move right here, and they go down, down, down. So because it's so viscous, you are going to actually, how do you say it? How you're going to move very, let's say, specifically the viscous fluid. So for example, as you can see, it goes down, and eventually it goes down, turns here, and starts going up. This one is also used for high viscosity. As you can see, it has the shape of the vessel. So all the viscous material that stays right here will move. There's also for a small one, you will have probably a very. So one of the benefits of your premium membership is that you can get Excel sheets, Word documents, and even some slideshows. Let me show you. For example, if you've been working with the course, you probably know that I have plenty of problems in Excel. I've been uploading some of these. You can check them, and once you get the idea, you will be able to study and play with the exercise and know, for example, parallel flow, what happens when you get plenty of friction in one side versus the other side. Or if you're doing a type 2 problem, you know that you don't have volumetric flow rate, so how can you assign cells in order to get your velocities. Also, you have here a system curve exercise and a pump curve exercise. Once you get that, you also have access for formulary and equations, so you may print it. If you are allowed to take notes for your exam, you can print many of these. So why not go and register for this awesome course, Incompressible Flow course. Something like this. So you're going to move all the viscous material. This one is very awesome. It's combined with with paddles, so they move. So this moves, and this one, guys, moves as well. And you have also other types. This one is combined between anchor and the helix. This might be used for a very viscous. Let's continue with the tank, containers, or whatever vessel. You know that eventually you are going to mix in a vessel or whatever container. So the typical application is tank, steel tanks, or let's say a metal tank. That it must be, of course, prepared for the material that you're going to mix. So for example, you have a very corrosive material, well, maybe the steel is not good enough. You might want other type of material. But the truth is that many tanks come in this type of materials, steel, and everything is steel. Even the propeller or impeller is steel, bottom is steel, pipes are steel. You have many types, for example, flat bottom, so you will have the pipe here, and probably you will either have one outlet right here, or you will need to install it and then take away. You have it for support, for example, easy to install pipes right here. Then you may use it horizontal, so you have it here, and well, there are many applications. So you have the baffles right here. Also, you want a container or vessel that supports the motor in the inlet pipe, outlet pipe, and baffles. And the sizes are from small containers to huge containers. Actually, this I will say is intermediate. You can find huge, very huge tanks of agitation. Baffles, why do we want baffles? To increase mixture. So imagine you are moving and then you get stuck with this point right here, because as you can see it's literally a wall. So you generate more mixture and then go, and then crash again, and then move, then do it and do it until instead of just watching this little guy going in a radial way, very beautiful, you're going to have a chaotic path. Once again, if you got your blender, go and check it out, because you can find some baffles right there. This one, some are very smooth, some are very aggressive. So they promote the radial circulation. So you have it right here. Instead of just going downwards, then they start going here and they promote mixture, chaotic paths, and so on. We have it here as well. Then shaft. Eventually you need something that connects the motor and the impeller. What's a shaft? It's essentially just a stick which will be able to mount the impeller and the motor. The motor will rotate the shaft and the shaft will rotate the blades. So this is the shaft, this is your motor, this rotates and this connects to your blades and they start moving. You can have one shaft, one long shaft, maybe two shafts, or even more shafts. You have many styles, but the most basic one will be the motor. It goes directly with the shaft. And of course, what about the motor? Well, it must make rotation. You must have something where to place it and install it. Very safe, because this vibrates. You don't want it vibrating and then your motor's being destroyed anywhere. You need to place a proper base right here. You also need a level indicator or sensor, for example these and these. There are plenty of sensors. I'm not going to talk about that because that is more into instrumentation and control of processes, but you have pneumatic, ultrasonic, magnetic, and of course mechanical. So this might be, you don't feel it, so it's not high, but this one feel it, so it's not empty. It's between empty and full. Very fancy. But of course, if you add another one, you can use, it's either half, more than half, less than half, or empty. So you may have this type. Actually, I used them before. You have it right here, and they move, and they make a pressure right here. So eventually you can go and read it right here, and you check out, and you see, oh, it's 60 centimeters. Normally, when you measure level, you measure it in centimeters or meter. You don't measure cubic meters or so. The level is normally measured in length units. Other fancy sensors, for example, this ultrasonic sends waves right here, then they bounce, and the time required to do that divided by 2, and the velocity will give you the distance, which is the height, and the height will show you the level. So it's very fancy actually. This was a free preview. You want to get full access, go to my incompressible flow course. The link is in the description of the video. You will get all access. Not only that, you get a very straightforward, user-friendly interface. So for instance, you were analyzing or studying pumps, you have it here, the pump block, and then you have the sections. If you were, for example, studying the types of pumps, you can go here, and you have all the classes right here. Not to mention that you also have introduction and conclusion of every one of these. So for instance, if you were studying positive displacement pumps, the video is right here. If you were studying positive displacement pumps in rotatory and reciprocal are also included here. Centrifugal pumps, which is a very important topic in this course, you have it right here.